Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you'll learn about AWS services. Today we are going to talk about how you can use Amazon Redshift Spectrum to access data from Glue catalog in Redshift cluster. So let's get started. First, try to understand why we need to use Amazon Redshift Spectrum. So when you're trying to build AWS data lake, AWS-based data lake, then you try to keep your data typically in two types of data store. You keep some part of data in the S3 bucket and some part of the data in Amazon Redshift. And there's a reason behind that. I mean, you can make a comparison why you want to keep data into S3 versus you want to keep data in Amazon Redshift. And I'm not saying that you have to keep data in these two resources or these two data stores only. I mean, you can keep all data in Redshift, you can keep all data in S3, or you can keep data in some other services like DynamoDB table, DocumentDB, or even RDS databases. But I'm talking about two most popular choices people have when trying to keep data in data lake. One is the S3 bucket, another is the Redshift. And why they will like to keep data in these two different stores in your data lake. So I'm talking from the generally speaking comparison. I really, in specific cases, things could be different. I totally agree. So what comparison I give here is a generally speaking comparison. It might not stand true in a very specific scenario, and those scenarios we can discuss separately. I mean, if you have any such scenario, you can definitely post me in the comment section and we can discuss about it. But now I'm going to compare these two data stores in data lake and why people like to keep this data in these different stores. First thing, going cost wise, keeping cost in S3 is very low. And if you try to compare keeping the like same amount of data you keep into Redshift but to keep into S3, the S3 cost is very low. Redshift cost is higher than S3. So that's the one thing. Cost is the one driving factor why people like to keep data in S3 versus over Amazon Redshift. But at the same time, if you see from the query performance point of view, Amazon Redshift has got a higher query performance compared to S3. And you have higher query performance in S3 because in Redshift because there you have control over your compute power and you can increase the compute power to get better query performance. However, in S3 you are using serverless technology, you are using Athena to query the data, and you can really not say Athena that give me a specific compute power. Athena gives you certain compute power. So generally speaking, again, you will find that the query performance in Redshift is better than query performance in S3. So generally cost and query performance are two primary drivers why one will like to have data in S3 versus Redshift. But there are mix and match scenario as well where you want to keep some data in Redshift and some data in S3 and both data stores become part of your data lake. Now let's see a few things from the use cases point of view. So for instance, one use case is pretty simple. If the customer says, I want a high performance query data, I'm going for a self-service scenario where I want to query terabytes of data to get my result right away in a high performant way, then of course Redshift is a better choice over S3. So you can keep your high performing query data in Redshift, while the data for which the query performance is not so important, that data you can keep into S3. So there's a one split scenario where high performance query data go to Redshift, while not so high performance query requirement data go to S3. Another scenario is that you can have your denormalized aggregated data in Redshift. So, but The line level data, the data on which this denormalized aggregation has been created, that data you keep inside Amazon S3. So you keep your lowest form of the data in S3, but you keep your aggregated form of the data in Redshift. That's another way people do split their data between Redshift and S3. And generally, in such scenario, people make their most of the query on the aggregated data, and in that case, they get their query from the Redshift. But sometime, if they want to know the line level detail for the aggregated data, they do have data in S3. You can get data from S3 as well. Third one I have seen is that if people are going for any kind of real-time reporting or dashboard or self-service kind of scenario, then they go for Amazon Redshift. But if people are going for more of a scheduled reporting where a report is, say, generated once in a day and then distributed to all the users, in that case, people go for S3 kind of storage because at that point of time, like for scheduled report, time is not critical, but in a real-time self-service reports or dashboard, time is critical, and that's why people go for Redshift. So these are three thinking I have seen when people try to split their data between Redshift and S3. Now, there are scenarios that, okay, I have a data lake and I have split my data in Redshift and S3, and there are a set of users who are trying to make a query. When they're trying to make a query, in their query, they bring part of data from Redshift, but they bring other part of data or drill down data from S3. And the one use case I talked about that, okay, you have your denormalized aggregated data in Redshift while your line level data on which this data has been aggregated, that data is in S3. And it could be a scenario that I am trying to create a report where I first get a denormalized aggregated database report from Redshift, but if some user at some point of time can want to have a drill down on any of the aggregated line to see, okay, show me the line level data to get some details from there, in that case you have to dig data from S3 as well. So there are query requirements and a lot of query requirements where you can simply not look into S3 or Redshift, but you have to look into data between S3 and Redshift to complete your query requirement. And in that case, actually, it becomes very important that when you query the Redshift cluster for your aggregated data, and then you want to go for your line level data, instead of you query the data from the S3, Redshift should somehow query data on your behalf. That means your interface for the report is not split between S3 and Redshift. You just talk to the Redshift, first get an aggregated data, and when you want a line level data, let Amazon Redshift talk to S3 to bring that data for you. So you talk only to Redshift, nothing else. Redshift is doing talk on your behalf to S3 to bring line level data. We need a communication like this so that from the reporting point of view, your interface is pretty simplified. You're talking to Redshift. It's not that you're talking to Redshift first and then S3 first and then trying to bring both data. That will be a nightmare thing to do, in my opinion. Well, technically feasible. I'm not denying that, but not a preferred way, I will say. So the preferred way is that you talk to Redshift and let Redshift talk to Amazon S3 on your behalf to bring data for you. And that's where this communication is required, where Redshift need to talk to S3, and comes Redshift Spectrum. Redshift Spectrum makes communication between S3 and Redshift. And the way it makes communication is that you can actually create external schema in Amazon Redshift to create kind of virtual tables, if I may use that word. Kind of you create a virtual table, not a physical table. There is no data into it. A virtual table, or we call it external table in Redshift terminology. But I like virtual word more. So you can create a virtual table in Amazon Redshift, which actually simply represent data stored into S3. And when you call this virtual table or external tables, then these tables simply bring data to you on demand from S3 bucket. So basically what we are talking about is that you create a presentation of S3 data in Amazon Redshift as an external table, and so that the user can query the aggregated data from Redshift table, and whenever it needs to query data from S3 bucket, it can query that data from the virtual table. Or you can create a join as well if you want. All those things are possible. And then when you talk to virtual table is talking to Amazon-based S3 data on your behalf. And this talking to on your behalf communication is possible through Redshift Spectrum. So how do I create this virtual table or external tables? There are two methods available. One is you can create external schema. External schemas which can talk to S3, which is based on S3 data. That's the one thing, external schema based on S3 data. Or you can catalog your S3 data. You can use Glue to catalog your S3 data, and then you create external schema on the top of this catalog. So two approaches available. You create this external schema or virtual table using S3 based data directly, or you talk to this data cataloged, which is actually catalog of your S3 based data. Now, both has got both are technically possible, but you try to create an external schema for S3 data. Actually, you create schema and create table per data set. Let's take an example that in S3 you have got 5 different data. You have customers, sales, order, invoices, one more table, one more data set. And so what you have to do in case of using S3 data-based approach, that you have to create 4 external tables for each of these data sets, one by one. Yeah. That's how you do that. So per data set, you create one external table. In case of catalog, it's pretty straightforward. When you catalog your data, all this data, all your invoices, orders, sales, customers, they're all cataloged for you. Then when you talk to the data catalog database, all the tables gets, the external table for all those catalog tables gets created. So you simply create schema based on Glue catalog database level. So in my personal experience, it is a less effort if you use the second approach. If you use the second approach, it's less effort to create communication between Amazon Redshift and S3 compared to talking to S3 directly. Second benefit is in the second approach, catalog approach, you are using catalog. And you know the fundamental rules of using data lake, that if you are bringing data, you should catalog it, because if you catalog it, your data is searchable and discoverable. That's another benefit you get. Since you are working with a searchable, discoverable data, you know what data you have in S3 bucket through the catalog. Simply talk to the catalog and create the whole communication. That adds another benefit in my opinion. So less effort and more visible data I see when I use catalog based approach. And this is the approach I'm going to discuss today, and I'm going to show you demo today later that how you can use catalog to talk to S3 data using Amazon Redshift Spectrum. Okay, so moving on. So how do I use Redshift Spectrum? It's pretty simple and straightforward. 4-step process, nothing more than that. And these 4 steps we are going to demo as well. First, you catalog your S3 data. So you have data into S3 bucket. You simply use AWS Glue data catalog to catalog it, whether you manually catalog it or you use AWS Glue crawler to catalog it, up to you. Then you create an IAM role for Redshift, and this IAM role you give permissions so that it can access data from the catalog. Then you launch Redshift cluster, with this IAM role. If you by assigning this IAM role to this Redshift cluster, you are simply giving Redshift cluster permission to be able to talk to the Glue catalog. Now, not that you can do this kind of configuration with a new cluster launch only. No, if you already have a Redshift cluster up and running, you can simply associate this role to the Redshift cluster, and you're good with the step number 3. And finally, you create external schema, and creating external schema is simply running some SQL query, nothing more than that. And we'll discuss about what query you have to write. So these are the 4 steps process which you need to follow to make Redshift Spectrum talk to S3 bucket for your Redshift cluster. Now, 2 very important things we need to understand here. First is what is this IAM role? So this IAM role is for Redshift cluster, which actually gives Redshift permission to talk to S3 bucket, and here you provide 2 types of policy. You give a read-only access to S3 bucket, and you also give a Glue console full access. Now, to be very honest, I mean, these 2 are good actually, but these 2 actually give a lot more permission to Redshift bucket. So what you can do that you can make S3 read-only access, but not to the entire S3 service or all the buckets, but you can create a custom policy which can give S3 read-only access to only certain bucket. And simply the buckets where you have the data. So that Redshift Spectrum does have a read-only access, but only to certain buckets, nothing more than that. That way you can improve the S3 read-only access, or you can mature the security of S3 read-only access. And in the second one, where we are giving AWS Glue console full access, instead of giving AWS console full access on all the resources, you might want to restrict it to those catalog tables and database to which you want Redshift Spectrum to talk to. So that's another thing you can do. So you can restrict each of these accesses to specific resources, then a generic one, then to all the services, all the resources, and that way you can make security more tight. Something I'm not doing today in the demo, but I thought it's worth talking. And if you have any confusion around how to do that, just let me know. I will more than happy to discuss that in the comment section. Now, how do I create this external schema? You simply run a SQL query, and that SQL query is create external schema. Then you give this schema name from the catalog, and from the catalog database, and this is the catalog database name. And then simply this is the Redshift Spectrum Redshift IAM role. That's it. It's pretty straightforward. So you're simply saying, for this database, create an external schema inside Redshift Spectrum using this role. Okay, and then last statement is that just like if this database does not exist, then create it. If it does exist, simply do nothing. Now, when you do that, what happens is that all the tables inside this catalog database becomes a table, become an external table, or those virtual table, the word I'm using inside your external schema, and then you can simply make query using the external schema. So for instance, suppose there's a sales external table inside this schema. I can simply make a query like this, where I can say select count star from external schema dot external table, and that way I can make query in Redshift cluster, and Redshift cluster will simply talk to the S3 bucket using a Spectrum to fetch data for you. So fantastic. It's very easy to do. I'm going to do it anyway, and you will get the experience of it. So what we are going to do for the demo is pretty straightforward. We have got an S3 bucket which has got sales and customers 2 data sets. I'm simply first going to catalog it, and then I will configure Redshift Spectrum to access this data using Amazon Redshift. That's what we are going to do. So let's jump onto AWS Management Console. So here we are at AWS Management Console. I have this Dojo data set bucket where I've got customers and sales 2 folders, and these folders have got 2 CSV files, and these CSV files actually keep some customers and sales data. Yeah, it's pretty straightforward setup. Sales data, CSV files. Now, I have got these buckets created. The first thing I need to do is that I need to go to AWS Glue console, and I need to create a database. So I'm going to first catalog it, right? In order to catalog my S3 data, I'm going to create first a database. So I'll simply add a Glue catalog database. Okay, and this database name is, I will simply say Dojo database create. So my database is created. Now what I need to do is that I need to crawl my S3 bucket to simply catalog my S3 base data into this database. For that, I will go to the crawler and I'll say I want to add a crawler. I will give this crawler a nice name. Okay, and I'll call it S3 crawler or data crawler. Next, okay, I keep this thing at the data source as S3, crawl all the folders. Then in S3, where is my data? My data is in S3 bucket. If I go to Dojo datasets, yeah, here we go. Simple. So I'm simply going to give a top level the location, and there are two folders, sales and customers under it, and they have my sales and customer data. I move next. Do you want to add another data source? No, I think I'm good. I use an existing, I have created an IAM role for Glue, and I'm simply going to give that a role a permission. Okay, and you can see here what it says. Okay, I'm going to run it on demand. This table, whatever the crawler output is, and crawler output is actually catalog table, that should be stored into this Dojo database. Next, and I simply finish it. So now my crawler is ready. I simply click on this link to run it. So it will start executing my crawler, and it will take some time. So what I'm going to do, I'm going to use this time to create few more resources. So my step 1 is in progress. My step 2 was to create an IAM role, which I can use to give Redshift cluster access. So I go to IAM management console and then click on the create role. So it will simply, it's using a new console, so it looks very nice. So I click on the create role button to create a new role. This role I am creating for Redshift, and then it will say okay, Redshift, and then in Redshift I want to use Redshift customizable. Next. Then I need to give it certain permission. The first one is Amazon S3 read only access. Here we go. That's the first one. And the second permission I want to give, policy I want to is AWS Glue console full access. Here we go. Yeah, console full access. So these two permission I give to the role. Move on to next. Here I have to give the role name, and I'm giving this a role name called Dojo Redshift Spectrum role, which is for Redshift Redshift service, giving two accesses: AWS Glue console full access and Amazon S3 read only access. And then I simply create the role. So I'm using the new console, and that's why if you're using an old console, your UI might look different, but there also you do the same type of configuration. So now my IAM role is created. I will have a look at my at crawler, and you can see my crawler has actually finished, and it has created two tables for me. So I will come back to here again. Let's launch Redshift. So my step number 2 is done. Now I'm going to launch an Redshift cluster using this IAM role, and let's see how it goes. So I go to my Redshift management console, click on this clusters over here, and I simply say I want to create a cluster. And here I just use the default name, and then I simply go for production, but in this case I don't want to use a very costly cluster, so I'll go for DC2 large, and I just need one node. That is more than enough for me. Okay, and generally when I do this kind of demo, guys, I simply kill my cluster after my job is done. Then I go to AWS user, I go to AWS user password, and I simply give my password here. Okay, and then here here I have to provide my IAM role, the IAM role which I created for the Redshift cluster. So I click on associate IAM role. It will show you Dojo Redshift Spectrum role listed over here. I can simply select it, and that's it. I don't need to change anything in my additional configuration. So pretty straightforward. I kept the name default. I went for production, selected DC2 large, one node, and I said that, yeah, if you keep it running, this is the charge you pay, but I generally do this kind of demo, then I kill it right after that. This is my username. I gave some password, and then most important, I selected the IAM role. If you don't do this, it will not work for you, and you create the cluster. So don't save. So here my cluster is being created. While the cluster is being created, what I will do is that I will like to show you how the schema of the two tables look like. So I've got sales and customers two data, which are into sales and customers folder. If I open the sales schema, it shows you this is how my data, my schema look like. The data look like in S3. This is the schema of the data look like in S3 bucket. Similarly, if I go to my customers, I can see how this is how my customers schema look like. So both schema are ready actually. Let's see if my Redshift cluster is ready, and then if it is ready, then we can actually start the whole to the step number 4. So my cluster is not ready yet. We'll wait for cluster to be ready, and once cluster is ready, we will move on to the step number 4. Okay, so my cluster is now available. So my cluster is ready for the use now. What I'm going to do is that, so my 1, 2, 3 steps is ready. My data is cataloged, IAM role was ready, then I launched an Redshift cluster with the IAM role. That part is also done. Now comes the 4th part, the moment of truth, where I'm going to create external schema for my data catalog and then be able to query my S3 based data using the external schema and data catalog. So for that, I will use query editor. So let me go to new version of query editor. We'll use everything new today. So we go to Redshift query editor version 2. Okay, I have been testing some queries, so let's delete it. And if I expand my Redshift cluster, it should connect to this Redshift cluster. I love this new UI, this new query editor, it's beautiful. And you can see here that it has got public schema and no table, so it's a plain vanilla cluster. So let's change a few things here. Okay, let's remove it. So first thing, we need to create an external schema. So what I'm going to do for that, I'm going to run the query I showed you. So the query is pretty straightforward. We are saying create external schema, then your catalog name. Okay, so this is the schema name, right? So like public is a schema here, by the way. So it's going to create one more schema. So in this, by the way, in this configuration, Redshift is a cluster, dev is the database, and this database, a database can have multiple schema. And then the resources like your tables, views, functions, stored procedure under the schema. So public is one schema. Public is one schema. What I'm going to do is and public is a local schema. That means this schema, the data in this schema is sitting on the Redshift cluster. Now what we are going to create is external schema where the data is not sitting on the Redshift cluster, but data is sitting in a S3 bucket. So that schema name is catalog schema. And then this catalog schema is based on Dojo database. Remember, simple Dojo database we created into the Glue catalog. And then it says which IAM role I'm going to use to create this, which IAM role has got permission. We have to mention that as well. And this is the IAM role. This is the same IAM role which we created earlier. In the IAM management console, and then finally, create this database if does not exist. So I'm simply going to run this thing and see the effect of it. So when I run it, it finishes in no time. Actually, if I come here and say, okay, I want to refresh my objects here. So you can see here now under dev, I have got a catalog schema. You can see here this arrow that shows that, oh, this is actually external schema. Okay, so see the catalog schema is here, and if I go inside that, you can see tables, and there are two tables, customers and sales, and both are also external tables. You can see here that this is an external table. That means the data for these tables does not exist here, but it is stored in S3 bucket in this case. Now I can simply say, okay, right click and say, hey, show me the table, or select table, and I run this query. So it's saying select star from dev, external schema, catalog schema, dot table name. And when I'm making this query, I'm making this query inside Redshift Spectrum like I'm querying a local schema, but no, I'm querying an external schema which is representing data from S3 bucket in this case. So I simply run it, and voila, I can see the customer's data right inside my Redshift Spectrum without going anywhere else. And I can change this simple query to sales here, and I can see my sales data as well. So you can see here I can query my S3 based data using a Spectrum from Redshift cluster. And when you are making this kind of query, it's not that you can only make query to the external schema. If you have some data, some table in local schema like public, and you want to make a join, even those things are also possible and not a problem at all. So that was about Redshift Spectrum to access data catalog. That ends the video, and I hope you like the video. If you like the video, please click on the like button. Please subscribe to my channel. And I always look forward to your feedback, whether it is for any new topic you want to talk about, or if I have made some mistake and you want me to correct, or you have any design or architecting questions which you want to discuss with me. Feel free to write your questions, your comments, your feedback to the comment section of YouTube channel, and I will be happy to respond to those comments. So I look forward to your comment to improve my content. I promise to come back again in a week's time with another such video. In the meantime, stay safe and have a nice day. Bye-bye.